Don't forget to subscribe and press the bell icon to never miss a video from testbook.com.
Hello friends, a very good evening to all of you. So by the way, so actually I was just practicing, so that's why Pranshu Mahajan is written over here. I had no intention of doing this, so I was just practicing my handwriting. Okay, anyways, so any student who is going to watch the video for the very first time, for them the information is that we are going through questions. So every day we will solve one question that will be related to some particular topic. And today's topic is liquids in relative equilibrium. That is from the second chapter of the subject, that is fluid statics. So in some books, the same chapter is written in, so the same topic is mentioned in fourth chapter also, like fluid dynamics. And the reason is because the Newton's second law of motion, which we write in this case, is very much similar, is actually the same as that of Euler's equation. इस मेथड में जो आप न्यूटन सेकंड लॉ ऑफ मोशन लिखते हैं, डिफरेंशियल फॉर्म लिखते हैं, वो बिल्कुल वैसा ही दिखाई देता है जैसा कि यूलर्स इक्वेशन है. इसलिए बहुत सारी बुक्स में ये टॉपिक जो है वो फ्लूइड डायनेमिक्स चैप्टर में भी मेंशन किया जाता है. And just for your information, so IRCON has released some vacancies. मेरे ख्याल से 34 वैकेंसी आया है. अभी मैंने चेक नहीं किया है कि what is the number of vacancies corresponding to mechanical, but you guys can check. So there are in total 34 vacancies. 1,000 rupees is the fee fee of the form, and you can check what are the मतलब respective points क्या हैं, further details क्या हैं, वो आप चेक कर सकते हैं. ठीक है. So guys, I think without wasting any time, आपका बिना time waste किए, let us start. So what it says कि there is a container and the total height of container is maybe 20 centimeter and the width of the container, that is 20 centimeter. So length of the container is 20 centimeter, height of the container is 20 centimeter, and perpendicular to plane of paper, the width is 1 meters. So perpendicular to plane of paper, the width is 1 meters. Width is 1 meters. Now this container has actually wheels at its base. So this container can move. And in the container, which is initially at rest, the level of water is up to this much point. So this height of water is 10 centimeters. So initially the container is at rest and the level of water, height of water in the container is 10 centimeters. Now the same container starts moving and actually the container goes up a plane. The container goes up an inclined plane. The container goes up an inclined plane. And the inclination of this plane is 30 degrees. So here is the inclination of the plane, that is 30 degrees. So they are asking you, if the container is moving with constant acceleration, then what is the value of acceleration such that water is just about to be spilled out? समझ रहे हैं आप? So what is the question? The question is, if the container is moving up the plane, then what is the value of acceleration so that the water is just about to spill out? Water is not spilling out, but if it will move further faster, the water will start spilling out. So this is the question. Okay. And before solving the question, I think it would be better if we quickly revise the concept. वैसे तो हमने क्लासेस में ये concept किया है और मैंने आपको एक बार अच्छे से ये concept पढ़ाया भी है. I think on YouTube also we have completely discussed this concept. But still it would be good if we quickly revise the concept. So what it says, so anyone who will join new, for them, this is the question. So a container is given to us. Container is moving up the plane. And the question is, what is the maximum possible value of acceleration so that water does not spill out of the container? So the liquid in this container is water. So obviously water means density of 1000 kg per meter cube. Now guys, First of all, please note that such kind of questions, they come under the topic of liquids in relative equilibrium. Now you will ask me, sir, what do you mean by liquid in relative equilibrium? So let us suppose there is an oil tanker, okay? And initially the level of oil is this much in the tanker. So there will be certain center of gravity of the tanker. Accordingly, there will be normal reaction on the tires, है ना? And the weight of the tanker, weight of the oil, that will be balanced by the normal reaction on the tires. Now this tanker, it starts moving. So everyone knows when the tanker will start moving, what will happen? The water at the back side, the oil at the back side, it will start rising up. And oil in the front of the tanker, it will start moving down. And finally, the oil will take a constant shape like this. So initially the level of water is horizontal. Initially the level of oil is horizontal. But when the tanker starts moving, the shape of the oil surface will change. And after some initial changes, the shape will become constant. So this is the final constant shape of the oil. Okay. So actually, whether this shape will be constant or not, that depends upon the acceleration. And I think we have proved this also, right? We have proved this earlier, that whether the shape of the oil will be constant or not, that will depend upon acceleration. If the acceleration is constant, the shape will be constant. If acceleration is variable, the final shape will be variable. So we are solving constant acceleration cases. Which cases? Constant acceleration cases. So if the tanker is moving with constant acceleration, the initial shape of the oil will change, and after some initial changes, the final shape will become constant. So what we have a situation where a tanker is moving with constant acceleration, and since the tanker is moving with constant acceleration, the final shape of the oil in the tanker is constant. Don't worry, this we can very easily prove that final shape is constant, and actually I have proved this a lot. Many times I have proved this. Now check. So when the tanker is moving, the liquid mass is moving along with it. But the shape of the liquid mass is not changing. This is the final constant shape of liquid mass. So final shape of the liquid mass is constant. That's why you will say the final shape of liquid mass is constant. Therefore, there is no continuous deformation in the liquid mass. Hence, the rate of shear strain is zero. Once the rate of shear strain is zero, the shear stress at any plane passing through any point, that will also become zero. तो अगर आपकी फाइनल शेप कांस्टेंट हो गई है, शेप कांस्टेंट हो गई है, तो रेट ऑफ शेयर स्ट्रेन जीरो हो जाएगा. रेट ऑफ शेयर स्ट्रेन जीरो हो जाएगा तो किसी भी प्लेन पे आप शेयर स्ट्रेस निकाल लीजिए, वो शेयर स्ट्रेस जीरो ही आने वाला है ना. सो इन सिचुएशंस को आप लिक्विड्स इन रिलेटिव इक्विलिब्रियम बोलते हैं. If a fluid mass is moving with a constant shape without any deformation, those situations are called as liquids in relative equilibrium. Okay. Now, I hope you remember I solved such kind of cases. So I solved a container where the container was moving in horizontal direction with constant acceleration. I solved a container where the container is moving in vertical direction with constant acceleration. And these cases, so if the container is moving in horizontal direction or inclined plane, that will replicate an oil tanker. And if we are talking of vertical motion, so that can represent a rocket engine, because in rocket engine there is a big fuel tank. In the tank there is huge amount of oil. So when the tank will move up with high acceleration, the pressure distribution in the oil is going to change, and accordingly the forces on the oil tank are going to change. So that's why such kind of calculations become important in our case. Now let me just make you revise the very first case that I discussed. Obviously the first case was when the container is moving horizontally with constant acceleration. तो container जो है horizontally move कर रहा है constant acceleration के साथ. So what did you guys told me? You guys told me that, sir, this is the level of oil in the container. And by the way, those students who have joined just now, so for them, this is the question for today. So there is a container. In the container, there is water level and the container is moving up the inclined plane. So what is the maximum possible acceleration value so that the water will not spill out of the container? This is the question for today. What is the maximum possible acceleration value so that the oil or water, basically water will not spill out of the container? Okay. Now guys, if you remember this situation, I hope you remember what I did is, and by the way, जिन्होंने टॉपिक नहीं किया, अगर किसी को भी टॉपिक में डाउट हो, पहले कभी सॉल्व नहीं कर रखा है, तो वो मुझे बता सकता है. I will definitely help you out and solve this for you, derive this for you. मगर अभी I am just assuming that you know the topic, you have done the topic at least somewhere, and you are ready to solve the question of it. ठीक है? पर अगर कोई डाउट है तो आप in between मुझे पूछ सकते हैं. Now guys, I hope you remember what I did. I said that let us suppose this is the coordinate system. This is a coordinate system. Okay. Then if we take a point x comma y, at this point there will be a fluid particle. So on the fluid particle, you can write down the Newton's second law of motion. So you will have minus 1 by rho del p by del x is equal to acceleration along x, minus 1 by rho del p by del y minus g equal to ay, and minus del p by del z equal to az. Minus 1 by rho del p by del z equal to az. Now you will ask me, sir, what are these? I hope you remember what I have done. This is the resultant pressure force on the fluid particle per unit mass. So along the x direction, which is horizontal direction, there will be only pressure force on the particle. So resultant pressure force is equal to mass into acceleration. Now we are writing per unit mass. So mass will be 1. Similarly, resultant pressure force on the fluid particle along y direction plus weight of the particle. Why the weight is negative? Because weight is downwards and y is vertically upwards. I hope you remember my sign convention. And similarly, the net pressure force along the z direction is equal to acceleration along z direction. So what I have done, I have simply written that for a fluid particle on position x comma y, we will have resultant pressure force plus resultant vertical force plus weight is equal to mass into acceleration. Since we are talking of liquids in relative equilibrium, the tau value is going to be 0. If the tau value will be 0, viscous force will be 0. That's why in none of these equations I have added viscous force. किसी भी equation में मैंने viscous force को add नहीं किया है. मैंने सिर्फ pressure forces और weight को add किया है. So along the horizontal there will be no weight component. So there is no weight component along x and z. Only weight component is along y direction. ठीक है ना? So what we have done, we have written the resultant pressure force per unit mass on the fluid particle. So I hope you remember, I always say what we will do to solve any problem of fluid mechanics, we take a fluid particle. For the fluid particle, we write down the Newton's second law of motion. We will get certain differential equations. Once we solve the differential equations, we will have our answer. है ना? Now have a look. In this particular case, the container is moving along horizontal direction. So acceleration along y is going to 0. Acceleration along z is going to be 0. So what we have? We have with us minus 1 by rho del p by del x is equal to a. So you can say that del p by del x is equal to minus rho a. So definitely pressure is a function of x. But del p by del x is a constant. If acceleration is a constant, then del p by del x is also a constant. So when del y by del x is equal to constant, this means y is a linear function of x, right? Y is a linear function of x. So pressure will be a linear function of x. Okay. Now similarly we will have minus 1 by rho del p by del y minus g equal to 0 because the container is moving along horizontal direction. So there is no motion of container along vertical direction. So there will be no motion of fluid particle along vertical direction. ऐसा ही है ना भैया, fluid mass की जो final shape है वो constant है. Fluid mass की final shape constant है, and fluid mass is moving along with the container. It is moving along with the container. So every particle is moving along the same direction. ठीक है ना. देखो क्या है, जब shape change हो रही थी, then some particles were moving up also. But after final constant shape is achieved, then every particle is moving only along the x direction. ठीक है, every fluid particle is moving only along the x direction. Now what you will have, you will also have minus 1 by rho del p by del z is equal to 0. So I think this equation tells you that del p by del z is equal to 0. So if del p by del z is equal to 0, pressure is not a function of z, है ना. Pressure is not a function of z. So this is more like 2D problem. ये तो एक 2D problem है. और यहां से आपको क्या मिलेगा, यहां से आपको मिलेगा del p by del y is equal to minus rho g. So pressure is a linear function of x, pressure is a linear function of y, pressure is not a function of z. So this is a 2D problem, right? Now I hope you remember I told you how to find out the final shape of water. So finding out final shape of water is very easy. So what you will do, you will say, sir, let us take any two random points. So one point is x comma y, other point is x plus dx comma y plus dy. I hope you remember this. So what is dx? Dx is the difference of x coordinates. Dy is the difference of y coordinate between the 2 points. So you guys always tell me, sir, in Eulerian approach, we write down pressure as a function of position. So we can say dp is equal to del p by del x dx plus del p by del y dy plus del p by del z dz. है ना? This is how you tell me. Now what is the physical meaning of this equation? Physical meaning of this equation is, sir, if two nearby points, their x coordinate, y coordinate and z coordinate, the coordinates differ by dx, dy and dz, then the pressure of the 2 points, it differs by dp. So here the pressure is P and here the pressure is P plus dp. So for two nearby points, the pressure difference is going to be minus rho A dx minus rho G dy plus 0. This is the pressure difference between two nearby points, right? दो नियर बाय पॉइंट्स के बीच में प्रेशर डिफरेंस ऐसे लिखते हैं. अब ये तो दो नियर बाय पॉइंट्स हो गए. सपोज बोथ द पॉइंट्स so x comma y and z also, and x plus dx comma y plus dy. So both these points, they lie on the top surface. So if both the points lie on the top surface, both points are exposed to atmosphere. In that case, the pressure difference between the 2 points. So what is the pressure here? 0. What is the pressure here? 0. So what is the pressure difference? 0 only. So you will say, if the 2 points lie on top surface, if the 2 points lie on top surface, the pressure difference between the 2 points is going to be 0, right? तो आपके जो 2 points हैं उनके बीच का pressure difference 0 आ जाएगा, ठीक है ना? Now please note, this was the pressure difference between any two random points. This is the pressure difference between 2 points which lie on the top surface of oil, because both of water in this case, because both the points are exposed to atmosphere. ठीक है ना? So for these two particular points, dp is equal to 0. Therefore, for these two particular points, minus rho A dx minus rho G dy, this is going to be 0. So for these particular points, dy by dx is equal to minus A by G. Now you will ask me, sir, what is the meaning of dy by dx? अरे भैया बहुत आसान है. So this is the top surface of water. This point is x comma y. This point is x plus dx comma y plus dy. So what is dy by dx? dy by dx is nothing but the tangent to x comma y, है ना? Slope of tangent to x comma y. Now you will ask me, sir, why this is negative then? Why? Very easy, because I hope you remember, if the container is moving in the forward direction, the water at back side will rise up and water at front side will fall down. So this will be the top surface of water. And I think when we find out the slope of any tangent, that is with respect to positive x direction, है ना? So slope is negative. Why? Because slope is tan theta. This theta is an obtuse angle, that's why. थीटा कैसा एंगल है? ऑब्ट्यूज एंगल है, तभी तो ये आपका जो स्लोप आ रहा है ये नेगेटिव आ रहा है. नाउ द बेस्ट पार्ट इज, इफ वी कंसिडर dy by dx, this dy by dx does not depend upon x comma y. This dy by dx does not depend upon x comma y. What do you mean by this? Actually, we have found out that for those points which lie on top surface of water, if we take a point x comma y, then the tangent is given as minus a by g. But this tangent, this slope, this does not depend upon x, it does not depend upon y. So the slope value does not depend upon the point. This means everywhere the slope is same, so top surface of water is a straight line. Top surface of water is what? Straight line. Sir, all mechanical engineering formula, how to get, sir? Acha. So, Muthu, beta, I'm not sure because currently I'm not presenting all mechanical engineering formulas. But a few days back I had a class of heat transfer. So in that class I did the entire revision of heat transfer. So we made some short notes and we wrote down all the formulas. Similarly, for fluid mechanics also we did a session, but fluid mechanics session went out lengthy. So I thought I will make short sessions and post it over here. So every teacher is posting some lectures, है ना? So what you do, you go through those revision sessions, and while doing those revision sessions, you write down all the formulas. क्योंकि या तो अगर आप किसी एकेडमी में पढ़ रहे हो तो वो एकेडमी आपको फॉर्मूला बुक्स प्रोवाइड कर सकते हैं, या फिर आपको खुद बनाना पड़ेगा, है ना? सो अगर आपके पास कोई फॉर्मूला बुक नहीं है तो आप फॉर्मूला बुक खुद बना लीजिए. सो जब आप व्हेन यू आर रिवाइजिंग ना, सो व्हाइल रिवाइजिंग यू रिवाइज in written form, you revise by writing. So you make some short notes, and in short notes you write down all the formulas. Okay? Now guys, check. So we have found out one thing. That if this is positive x direction, then the tangent of the surface of water tan theta, this tan theta is going to be minus a by g. And obviously, if I take the acute version of this alpha, then you can directly say, so tan alpha, that will become positive a by g, because tan of 180 degree minus theta is minus tan theta. That's why. So tan alpha is a by g. Now this we have proved when the container is moving horizontally. Then I also told you कि भैया we know that del P by del X is equal to minus rho A. So pressure, it is going to be a linear function of X. Similarly, del P by del Y is equal to minus rho G. But this is same as the hydrostatic law. So Y is the vertical direction. So instead of taking vertical direction upwards, let me take it as H. So del P by del Y can also be written as del P by del H. So H is the downward variable and Y is the upward variable. So this will become rho G. So I think this you can directly write P is equal to P naught plus rho GH. So if you go vertically downwards, you can directly use the hydrostatic law. But if you go horizontally, then you have to use this formula. है ना? Now what did you guys told me? So first of all, we always prove that the water level in the front, it will go down by some distance. Let us say x1. Then water level at the back will rise by the same distance. So my first proof is always this, that the fall of water in the front is same as rise of water in the back. Then I also find out what is the pressure prism on this surface. So once I know the pressure prism, I can find out the resultant pressure force. Similarly, what is the pressure prism in the front surface? So I can find out the force on the front surface. I hope you remember these things. So today also we will solve the entire problem. We will find out the pressure forces also. But first of all, let me find out the acceleration value. So I hope you got the method of finding out the shape of water that will be found out by dp equal to 0. Now what we have? So what we have is that a container is moving on an inclined plane with a constant acceleration. So again, what will happen? Initially, the level of water in the container, that was horizontal. But since the container is moving in forward direction, so some water will move backwards. And finally, the water will achieve a shape maybe like this. I'm not sure what will be the final shape of water. But one thing is for sure, that we want to find out the maximum acceleration value so that the water does not spill out. So I think if the container moves ahead in the forward direction, then at the front of the container water will fall down. At the back of the container water will rise up. So possibility of water to spill out, that is from the back side. So any possibility of water to spill out, that is from the back side. Ajay, beta, actually we don't have any kind of promo code. So if you are interested in our teaching, if you like our teaching, then you can directly go to Testbook and join. So there is no sort of promo code. But right now discount is going on, so you can decide according to it. ठीक है? So हमारा ऐसा कोई promo code नहीं होता है टीचर्स का, इंडिविजुअल टीचर्स का. वो जो डिस्काउंट होता है वो सभी स्टूडेंट्स के लिए एप्लीकेबल होता है, सभी टीचर्स के थ्रू एप्लीकेबल होता है. अच्छा, सो वेयर वाज आई? सो वन थिंग इज फॉर श्योर, दैट एनी वाटर दैट स्पिल्स आउट, दैट विल स्पिल आउट फ्रॉम द बैक साइड. नाउ एनीवन हु इज वाचिंग द वीडियो, so in case of horizontal motion, I had proved that water surface will become an inclined surface, but it will be a straight line. In vertical motion, we had proved that water surface will remain a horizontal plane. But what will happen if we are moving along an inclined plane? This we had not proved in the class. Inclined plane का question मैंने class में नहीं कराया था. So question will be, what is the situation when the container is moving along inclined plane? Whether the surface will be a straight line or the surface will be a curved line. So again we will follow the same procedure, the same standard procedure. What is the standard procedure? Standard procedure is कि भैया just take one direction as x and the other direction as y. Let me take the inclined direction as x because the container is moving along x. Now you take a point whose coordinates are x, y. At this point there will be a fluid particle. So for the fluid particle, when you will write down the Newton's second law of motion, that is the Euler's equation, you will say the resultant pressure force plus viscous force plus weight is equal to mass into acceleration. But since the final shape of the liquid is constant, because the container is moving with the constant acceleration, phi dot term is going to be 0. Therefore viscous stresses are going to be 0. So we will be left with net pressure force plus weight is equal to mass into acceleration. When you write this in component form per unit mass, you will have minus 1 by rho del p by del x, minus 1 by rho del p by del x, del P by del X minus. Now guys, please check. For any fluid particle, the weight will act along this direction, है ना? So for the weight, there will be a component along the inclined plane, that is W sin theta, and there will be a component along the vertical plane, that will be W cos theta. So mg sin theta, mg cos theta. So along the x direction, the weight component is mg sin theta. Definitely it is negative because it is along negative x. And we write every force per unit mass. So mg sin theta by m, that will be minus g sin theta, is equal to mass into acceleration along x. Now acceleration along x is a, and we are writing equation per unit mass. Similarly, you will have minus 1 by rho del P by del Y minus g cos theta, and obviously there is no motion along y direction, that is perpendicular to the plane. So this acceleration is going to be 0. And if you consider z direction, that is perpendicular to plane of paper, neither there will be a weight and neither there will be an acceleration because there is no motion along z. So we are left with these two equations. So what you will say? I think you will say del P by del X is equal to minus rho A plus G sin theta. And I think del P by del Y will be equal to minus rho A plus G, 0 plus G cos theta. So G cos theta. So this is the variation of pressure along x direction, variation of pressure along y direction. Obviously for a constant acceleration, this term will be a constant, this term will be a constant. So del P by del X is a constant. So pressure is a linear function of x. Similarly, pressure is a linear function of y. है ना? Okay. Now again, how will you find out the surface of water? How will you find out the shape of surface of water? So what you will do? So again you will say, sir, dP means the difference of pressure between two nearby points. अगर दो नियर बाय पॉइंट्स हैं तो उनका प्रेशर डिफरेंस कैसे लिखते हैं? डीपी लिखते हैं. मगर प्रेशर इज अ फंक्शन ऑफ एक्स वाई जेड. सो हाउ डू यू राइट डीपी? इट इज डेल पी बाय डेल एक्स डी एक्स plus del P by del Y dy plus del P by del Z dz. है ना? This is how you write pressure difference between two nearby points. Which nearby points? Whose coordinates differ by dx, dy and dz. तो ये मैं हमेशा सिखाता हूँ कि यार अगर दो पॉइंट्स हैं, उनके कोऑर्डिनेट डिफरेंस dx, dy और dz है, तो उनका प्रेशर डिफरेंस dp होता है, उनका टेम्परेचर डिफरेंस dt होता है, डेंसिटी डिफरेंस d होता है ना? और उसको इस तरीके से प्रेडिक्ट करते हैं थ्रू कैलकुलस. Now what is del P by del X in our case? So del P by del X in our case is minus rho A plus G sin theta. Now I think for us theta is given as 30 degree, है ना? So let me write down the value of sin 30 degree. So I think sin 30 degree will become 1 by 2. And I am taking G value as 10 meter per second square. तो क्वेश्चन को थोड़ा सा आसान बनाने के लिए मैंने क्वेश्चन में बोल दिया कि G value is equal to 10 meter per second square. So if G value is equal to 10 meter per second square, theta value is equal to 30 degree. So sin 30 is 1 by 2, 1 by 2 into 10, that is 5. So we will have 5. We will have 5. Okay. These are the conditions of the question. And this will become minus rho G. So G is 10 cos 30 degree, that is root 3 by 2. So minus rho 5 root 3. This is del P by del Y. So you will have, when you will substitute these values over here, I think you will have minus rho A plus 5 dx minus 5 root 3 rho dy, and del P by del Z is 0 only because Z is horizontal, perpendicular to plane of paper. No weight component, no motion. So this is the final equation. Difference of pressure between two random points. But again, if the 2 points lie at top surface of water, both the points are exposed to atmosphere. So for the 2 points, the pressure difference is going to be 0. So again, you will say for 2 points, for two nearby points lying on top surface of water, dp value is equal to 0, right? But for any two random points, कोई भी दो random points के लिए dp क्या होता है? dp तो इतना होता है. कोई भी दो random points के लिए dp इतना होता है ना? So I think what you will say, therefore, for these 2 points, minus rho a plus 5 minus 5 root 3 rho, that is equal to 0, right? ये आपके पास कंडीशन आ गया, dp वैल्यू आ गया, थोड़ा सा गड़बड़ हो गया. सो माइनस, यहाँ पे देखिए क्या प्रॉब्लम है, यहाँ dx है ना और यहाँ dy है. dy by dx is going to give you the slope of the surface. So I missed out 2 important terms. I think I am hungry now. So minus 5 root 3 rho dy equal to 0. Now check, rho is a common term. So dy by dx, that will be equal to minus a plus 5 by 5 root 3. So this is the slope of top surface of water. What is this? This is the slope of top surface of water. So if the water is moving up the inclined plane, the plane has an angle of 30 degree and the acceleration of the container is constant. So this is the slope of top surface of water. ठीक है? सर मैं मैकेनिकल इंजीनियरिंग स्टूडेंट हूँ, 2018 का पास आउट हूँ. सर मैं एसएससी जेई और एई की प्रिपरेशन करता हूँ, लेकिन मेरा एसएससी जेई में 70 मार्क्स आया है, बहुत दूर हूँ, क्या करूँ अब? अच्छा प्रदीप बेटा, बिल्कुल भी घबराना नहीं है, ठीक है? सो अभी तो मैं इससे गेट की क्लास ले रहा था, बट आप मेरे साथ एक काम कर सकते हो, आप मेरे को कांटेक्ट कर सकते हो इस नंबर पे, तो हम कंप्लीट डिस्कशन कर सकते हैं, आराम से डिस्कस कर सकते हैं कि प्राइवेट जॉब और क्या करना चाहिए. ठीक है, तो अभी तो मैं कंटिन्यू करता हूँ इस डिस्कशन को कंटिन्यू करता हूँ, बट प्लीज फील फ्री टू कॉन्टैक्ट मी. अ लॉट ऑफ स्टूडेंट्स कॉन्टैक्ट मी, समटाइम्स कॉलेजेस ऑल्सो कॉन्टैक्ट मी फॉर मेंटरशिप, तो आप भी मुझसे बात कर सकते हैं. ठीक है, बिल्कुल भी घबराना नहीं है. देखो ये तो चलता ही रहता है लाइफ में. लाइफ अगर आसान होती सभी के लिए आसान होती तो फिर वो लाइफ नहीं कहलाती. मुश्किलें तो आती हैं, बट उससे घबराना नहीं है. जस्ट कॉन्टैक्ट मी एंड वी विल डिस्कस दिस प्राइवेटली. ठीक है, ओके, सो लेट्स कंटिन्यू. सो दिस इज द स्लोप ऑफ वाटर. सो अच्छा, सो एक्चुअली पता क्या है, क्यों बोला कॉन्टैक्ट करने के लिए? बिकॉज आई मस्ट बी अवेयर ऑफ योर करंट सिचुएशन ऑल्सो, कि आपका फाइनेंशियल सिचुएशन क्या है. मान लो अगर फाइनेंशियल सिचुएशन वीक है और मैं बोल दूं कि तैयारी करो बैठ के, समझ रहे हैं आप, तो कुछ बात नहीं बन रहेगी. तो हमें आपकी सिचुएशन भी समझनी पड़ेगी कि क्या क्या करना चाहिए और बीटेक में कैसा प्रिपरेशन है, बीटेक में आपका कैसा स्कोर रहा है, ये सारी चीजें भी देखनी पड़ेंगी. ठीक है, तो घबराना नहीं है, जस्ट कॉन्टैक्ट मी. दिस इज 5, नंबर 5. मैं दोबारा लिख देता हूं. हाँ, अब ठीक है. आई थिंक दिस इज क्लियर नाउ. ओके, okay, so guys, this is the slope of top surface of water. Now you will ask me, sir, why we have found it out? Actually it's very easy, it's very simple. So first of all, again, the slope at point x comma y, it is a constant. This means slope does not depend upon the point. So the slope of top surface of water is a constant. Therefore, top surface of water, it will have a straight line shape. What it will have? It will have some straight line shape, है ना? So if this is your container, container is moving up the inclined plane. So maybe this is the slope of top surface of water. Now again the slope is negative, and it's true only. Why? Because of the fluid is moving in x direction. If the fluid is moving in x direction, then water at the back will rise up, water at the front will fall down, and the tangent that will make a slope of obtuse angle with the positive x direction. So tan obtuse angle, tangent of obtuse angle, that is negative only. However, this angle alpha, this will be a positive term. Now in our case, how much is the slope? It is minus a plus 5 by 5 root 3. So you will simply say tan of theta is minus a plus 5 by 5 root 3. This is tan theta. So if I talk of only tan alpha, that will be a plus 5 by 5 root 3. Now you will ask me, sir, why you have done this? See, this is the final shape of water when the water is about to spill out. So, basically this final shape of water is constant and water is just about to spill out. If the acceleration is constant, the shape will remain like this and water will not spill out. But if the acceleration increases, the shape will change a little and water will spill out, है ना? अगर acceleration constant रहती है तो पानी की shape ऐसी रहेगी और पानी यहाँ से spill out नहीं करेगा. मगर acceleration की थोड़ी सी भी value बढ़ा दी तो यहाँ पे पानी और नीचे जाएगा, यहाँ पे पानी और rise up करेगा तो पानी spill out करना शुरू कर देगा. So this is the condition when water is just about to spill out. It is not spilling out, it is about to spill out. So this is the shape of water when the water is moving with constant acceleration. Container is moving with constant acceleration. And when the container was at rest, this was the shape of water. How much was this height? 10 centimeter. How much is this length? 20 centimeter, right? So what is the volume of water? 10 centimeter by 20 centimeter by 1 meter, है ना? So if I want to write it down, I think I can write 0.1 meter, 0.2 meter into 1 meter. So this will become 0.02 meter square, meter cube. How much is this volume? 0.02 meter cube. Or you can simply say 200 centimeter square into 1 meter. This is the volume of water. Later on also, water is not spilling out. So later on also, total of volume of water will be 200 centimeter square into 1 meter. Now check. This is the final shape of water. I think I can divide it into two parts. One is a triangle and the other one is a rectangle, right? है ना? Now, what was the total height of container? Total height of container was 20 centimeters. How much was it? 20 centimeter, right? Now, let me say the height of triangle, only the height of triangle, that is small h. And I think if I use this angle alpha, I can say, tan alpha is equal to h by 20 centimeter. If h is in centimeter, so tan alpha will be h by 20 centimeter. Furthermore, if I write the volume of water, how much will be this rectangle? So height of this rectangle is 20 minus h centimeter. Length of the rectangle is 20 centimeter and width perpendicular to plane of paper is 1 meter. So this much centimeter square into 1 meter. How much is the triangular part? So half into base into height. That will be half into h into 20 centimeter square. This is the area of triangle into perpendicular width, which is 1 meter. तो हमने रेक्टेंगुलर पोर्शन का वॉल्यूम निकाल लिया, ट्राइंगुलर पोर्शन का वॉल्यूम निकाल लिया. सो व्हाट यू विल डू, यू विल राइट डाउन द टोटल वॉल्यूम ऑफ वाटर. So total volume of water in the final shape, the total volume of water in final shape is the volume of triangular part, so this is in centimeter, meter, plus the volume of rectangular part, 20 minus h centimeter into 20 centimeter into 1 meter. So initial volume of water is same as final volume of water because water has not spilled out. So these terms are in centimeter, this one is in meters. Similarly, these terms are in centimeter, this one is in meter. These terms are in centimeter, this one is in meter, है ना? तो आपको units की tension लेने की जरूरत नहीं है. Now this will cancel out, this will become 10. So how much you will have? You will have 10H plus 400 minus 20H, and this will be equal to 20. Now you will have minus 10H is equal to minus 200. So H value is equal to 20 centimeter. So when the water is just about to spill out, the H value is equal to 20 centimeter. है ना? Now check for yourself. Kindly check for yourself. So H value is equal to 20 centimeter. So what is H? H is the height of triangle. H is the height of triangle. So height of triangle, that is equal to the height of container. This means the final shape of water. So height of triangle is equal to height of container. So final shape of water will look like this. This is how the final shape of water will look like, right? So we have got the final shape of water also. This is 20 centimeter, 20 centimeter, 20 centimeter, 20 centimeter, 20 centimeter, है ना? But tan theta, which is equal to, tan alpha, which is equal to a plus 5 by 5 root 3, this is also equal to h by 20. That is 20 by 20 now, है ना? So 20 by 20, that will become 1. So a plus 5 by 5 root 3 equal to 1. So a is equal to 5 root 3 minus 5. That will become 5 into root 3 minus 1. So this will become 5 into 0.732 something. So this value is equal to 0, 6 and then 1. So 3.66 meter per second square. तो जब आपकी एक्सेलरेशन की वैल्यू 3.66 मीटर पर सेकेंड स्क्वायर आ जाएगी तो उस केस में क्या होगा? उस केस में फाइनल शेप ऑफ वाटर ऐसी होगी. दिस विल बी द फाइनल शेप ऑफ वाटर एंड वाटर विल बी अबाउट टू स्पिल आउट फ्रॉम द टॉप एज. वाटर जो है वो टॉप एज से स्पिल आउट कर जाएगा. समझ रहे हैं आप? ठीक है ना? सो दिस इज द मैक्सिमम पॉसिबल एक्सेलरेशन वैल्यू विदाउट द वाटर गेटिंग स्पिल्ड आउट. सो मैं फटाफट से क्विकली आपको मेथड रिवाइज करा देता हूं. सो देखो मैंने क्या मेथड सॉल्व किया. सो गाइज इन द क्वेश्चन इट वाज सेड that the container is moving on an inclined plane with the constant acceleration. So we know what will happen. Water in the front will go down, water in the back will go up, and finally water will achieve a constant shape. Now it says what should be the maximum acceleration so that the water is just about to spill out. This means final shape of water will be something like this. This point will intersect with the top point of container, है ना? So what I did, this I am sure water is just about to spill out. It is given in the question. Now I found out the slope of top surface of water. This means I can divide the total shape in a rectangle plus triangle. But initial volume of water is equal to final volume of water. And also this theta, this alpha, this tan alpha is equal to height of triangle by the base. So what I got first of all I got that the height of triangle is equal to 20 centimeter. Same as that of container. So I found out this will be the final shape of water in the container. है ना? And once I found out this, using the value of h, that is tan alpha is equal to h by 20, I found out the maximum possible acceleration also, corresponding acceleration also. So मेरे को maximum acceleration मिल गया है. ठीक है ना? अब क्वेश्चन ये आता है सर we found out the final shape. Can you find out that भैया this surface of water is in contact with the container? this surface of water, this surface of container is in contact with water. How to find out the pressure force on this surface? है ना? Similarly, this surface of water is in contact, this surface of container is in contact with water. How to find out the pressure force on the surface? This question can be asked. So what I will say, actually it's very easy. How? So this is the y direction and this is the x direction, right? Now what do? You say कि भैया, let us consider only the water element. So this is the water element, and obviously the water element is moving along the x direction. So there are two methods and I am telling you both the methods. So water element is moving along x direction, that is along with the container. Now water element will have its own weight. So weight will have two components. One is W sine theta and the other one is W cos theta. Also, the water element is in contact with the surface of the container. So this force will be for pressure force between the water and the surface of container. So let us call this as pressure force along x direction. Similarly, here also there will be a pressure force along y direction, and I think this is what we want to find out. Pressure force applied by solid surface on the water is same as pressure force applied by water on the solid surface. It is same as the pressure force applied by water on the solid surface, है ना? तो अगर आप ये find out कर लेते हैं, you will be able to find out this. If you are able to find this, you will be able to find out this, right? So what we can do? We can solve the free body diagram of water element. So what you will say? You will say pressure force along the x direction minus W sine theta is equal to MA. Now you can find out the mass. How? You know the volume of water. Volume of water multiplied by density. So that will become rho into 10 centimeter into 20 centimeter, and also you also know the acceleration value, which is 3.66 meter per second square. So right hand side is known to us. How do you write W sine theta? That is mg sine theta. This is also known to us. So when you take it on the other side, you will get the pressure value. You will get pressure force value. That will be MA plus W sine theta. Similarly, when you apply the Newton's second law of motion along y direction, so what you will say? You will say FPy is equal to W cos theta. तो पूरे water element का, मैं single particle की बात नहीं कर रहा हूं. I'm not talking of single particle. I'm talking of the entire water element. So for the entire water element, you can use the Newton's second law of motion and find out the pressure force between the water element and the solid surface. Or we can go by other method also. How? Sir, we know how the pressure varies along y direction. So how does the pressure vary along y direction? Del P by del Y is equal to minus rho A plus G cos theta. We know the value of A, which is 3.66 meter per second square. Theta is 30 degree. So cos 30 degrees root 3 by 2. है ना? So this value is known to us. So what was y direction? So if this is your container, this was your y direction. But like you do in hydrostatic law, we denote another direction h, which is opposite to y. So what you will have? You will have dp by dh is equal to rho of a plus g cos theta. है ना? Now if dp by dh that is equal to rho g, then pressure is equal to P naught plus rho gh, है ना? As we do in hydrostatic law. Similarly, if dp by dh is equal to rho a plus g cos theta, then you will have pressure is equal to P naught plus rho a plus g cos theta h, है ना? So what you will say? You will say, sir, this is the top surface of water. From the top surface of water, if I move along h direction, then at any point I can write the pressure in this manner. Now this point is exposed to air, atmospheric air. So P naught value is going to be 0. है ना? and pressure is a linear function of H. I think H value is equal to 20 centimeter for the bottom. So at the bottom, you can find out pressure value. So rho will be 1000 kg per meter cube, A will be 3.66 meter per second square, and theta will be 30 degree. H value you know, that is going to be 20 centimeter. So what you are going to say? You will simply say that, sir, this means the pressure at the top is going to be 0. Pressure at the bottom can be found out, and we know that pressure is increasing linearly with H. So this will be the pressure prism. The volume of pressure prism will give us the pressure force. Secondly, water surface is like this. So there is no contact with the front surface. So there will be no pressure force at the front. Thirdly, Pascal's law says pressure at a point is same in all direction. So at this point pressure is 0. So at this point also pressure will be 0. At this point pressure we have already found out. So here also we know the pressure value. So at the bottom surface the pressure distribution is like this. So we know the pressure distribution of bottom also. So volume of this pressure prism, it will give us the pressure force. ठीक है ना? So इस तरीके से आप सभी surfaces का pressure force भी find out कर सकते हैं. So it's the same concept which I do in every time I teach this subject. ठीक है? So GATE exam में from this topic, most probably you will get horizontal acceleration or vertical acceleration, or you might get that cylinder question, cylinder rotating about its axis. ठीक है ना? तो अगर आप लोगों ने इस क्वेश्चन के इस टॉपिक के क्वेश्चन प्रैक्टिस नहीं किए हैं तो आप 4 क्वेश्चंस, इनफैक्ट 5 क्वेश्चंस प्रैक्टिस कर लीजिए. वो 5 क्वेश्चन कौन कौन से हैं? हमारे पास एक कंटेनर है जो हॉरिजॉन्टल डायरेक्शन में मूव कर रहा है विद कांस्टेंट एक्सेलरेशन. फाइनल शेप ऑफ टॉप सरफेस ऑफ वाटर निकालो, प्रेशर फोर्सेस फाइंड आउट करो. ठीक है? सेकेंडली, कंटेनर है वो वर्टिकल डायरेक्शन में मूव कर रहा है विद कांस्टेंट एक्सेलरेशन. अगेन टॉप सरफेस ऑफ वाटर का शेप निकालो, प्रेशर फोर्सेस ऑन दी ऑल दी सरफेसेस निकालो. इंक्लाइंड प्लेन का क्वेश्चन हो गया. एक सिलेंडर है, पानी से भरा हुआ है, अपनी एक्सिस के अबाउट घूम रहा है, फोर्स्ड वोर्टेक्स बना रहा है. पानी का शेप कैसा बनेगा? पैराबोलॉइड बनेगा. और बॉटम सरफेस पे प्रेशर फोर्स क्या आएगा? फाइंड आउट करो. और एक क्वेश्चन और ट्राई करके देखना अगर टाइम लगे तो, अदरवाइज लीव आउट कर देना. गेट एग्जाम में अभी तक ये क्वेश्चंस पूछे नहीं गए हैं लास्ट 20 इयर्स में, सो इनके आने के चांसेस भी कम है. बट क्योंकि अब गेट डिफरेंट टाइप ऑफ क्वेश्चंस पूछ रहा है आजकल, तो थोड़ा सा अच्छा रहेगा अगर आपके पास टाइम हो तो प्रैक्टिस करके देख लें. सो हमारे पास एक YouTube मैनोमीटर है. इस YouTube मैनोमीटर में इनिशियली पानी का लेवल इतना था 20 सेंटीमीटर. ओके, और ये YouTube मैनोमीटर को क्या करते हैं? इस एक्सिस के अबाउट रोटेट करते हैं. सो राइट हैंड साइड लिम्ब इज एट अ डिस्टेंस ऑफ 10 सेंटीमीटर फ्रॉम एक्सिस ऑफ रोटेशन. लेफ्ट हैंड साइड लिम्ब इज एट अ डिस्टेंस ऑफ 20 सेंटीमीटर फ्रॉम एक्सिस ऑफ रोटेशन. एंड मे बी दिस एरिया ऑफ क्रॉस सेक्शन, इसको कितना लोगे? 5 mm स्क्वायर ले लो, बहुत छोटा एरिया ऑफ क्रॉस सेक्शन है. ओके, कुछ भी रीजनेबल वैल्यू ले सकते हैं. 10 mm स्क्वायर ले लीजिए, चाहे 10 mm स्क्वायर ले लीजिए. ओके, सो माय क्वेश्चन इज, व्हाट विल बी द फाइनल हाइट ऑफ वाटर इन द लेफ्ट लिम्ब और राइट लिम्ब? What will be the final height of water in the left and right limb? ठीक है? And this omega you can take how much? This omega you can take pi radian per second. थोड़ा ज्यादा हो जाएगा, pi by 6 radian per second कर देते हैं. ओके, pi by 6 radian per second. ठीक है? सो इसको ट्राई करके देखो. हाँ, सो विशाल बेटा, ये क्वेश्चन तो मैंने होमवर्क के लिए दिया है, और ये जो क्वेश्चन कराया है ये मैंने एज्यूम करके कराया है कि आप लोगों ने ये टॉपिक किया हुआ है. सो जिन स्टूडेंट्स ने ये टॉपिक नहीं किया हुआ है वो डेफिनेटली मुझसे पूछ सकते हैं और उनको मैं टॉपिक सिखा सकता हूं. ठीक है? सो प्लीज डू लेट मी नो. अगर आप लोगों ने ये टॉपिक नहीं किया है सो मैं आप लोगों को सिखा दूंगा, और अगर टॉपिक किया हुआ है तो वेल एंड गुड. फिर हमने सेम प्रोसीजर फॉलो किया है जो प्रोसीजर हमने क्लास में भी फॉलो किया था. सो प्लीज डू लेट मी नो क्या चाहते हो. समझना चाहते हो या कर पाओगे? समझना चाहते हो या कर पाओगे? डू लेट मी नो। और ये मैंने एक होमवर्क क्वेश्चन दिया है। ये मैं क्या करता होता हूँ, मैं एक क्वेश्चन कराता हूँ जिसमें कंटेनर रोटेट कर रहा है। फोर्स्ड वोर्टेक्स का फॉर्मेशन होगा। हम सॉल्व करते हैं कि बीच में पानी कितना नीचे जाएगा, टॉप में साइड्स में पानी कितना ऊपर आएगा, और उनकी टॉप सरफेस की शेप कैसे बनेगी। अच्छा, नहीं किया हुआ है, ये टॉपिक नहीं किया हुआ है। ओके, सो आई थिंक मेरे ख्याल से कुछ स्टूडेंट्स ने ये टॉपिक नहीं किया हुआ है। अच्छा, अभिलाष, हाँ ये अलग से रिकॉर्ड किया था अभिलाष। हाँ अभिलाष, एक काम करना, ये वाला जो चैनल है ना, इस चैनल पे मैंने 2-3 वीडियोस बनाया है जिसमें ये पूरा टॉपिक एक्सप्लेन किया है। जस्ट अ सेकेंड, जस्ट मेरे को थोड़ा सा टाइम दो जरा, 1 मिनट में चेक करके बताता हूँ। 1 मिनट में चेक करके बताता हूँ। मैंने यहां पर ये कंप्लीट टॉपिक ना सॉल्व किया है। मैं 1 मिनट दिखाता हूं आपको अभी, 1 मिनट बस। हाँ 1 मिनट गाइस। जिन लोगों ने ये टॉपिक नहीं किया है उनको घबराने की बिल्कुल जरूरत नहीं है, क्योंकि मैंने इस टॉपिक की ना वीडियोस बनाई हुई है और मैं आप लोगों को वो वीडियोस शेयर करता हूं। 1 मिनट रुकना गाइस, बस 1 मिनट रुकना। हाँ ये रहा गाइस, ये रहा। Actually I have solved this topic over here, and let me give you the link of the same. ये रहा अभिलाष। अभिलाष चेक, मैंने एक लिंक भेजा है बेटा, काइंडली चेक, मैंने एक लिंक भेजा है। एक्चुअली जब मैंने वीडियो कराया था ना, तो मैंने वीडियो में भी बताया था कि जब आप, मेरे ख्याल से आप रेगुलर कोर्स के स्टूडेंट हो, है ना। जब मैंने वो वीडियो बनाया था तो मैंने बताया भी था कि मैं स्पेशली यूट्यूब पे जाके एक वीडियो रिकॉर्ड कर रहा हूँ। वो वाला वीडियो है ना। ये देखो, ये यहाँ पे बनाया हुआ है। फर्स्ट पार्ट भी है, सेकंड पार्ट भी है, और लेट मी चेक अगर इसका कोई थर्ड पार्ट भी हो। लेट मी चेक अगर इसका कोई थर्ड पार्ट भी हो। नहीं, शायद इसके 2 ही पार्ट्स हैं। एक बार करके देखो, अगर सॉल्व हो गया तो वेल एंड गुड, और अगर सॉल्व नहीं हुआ तो मुझे आप लोग पर्सनली मैसेज ड्रॉप कर देना। मैं कल सुबह, या कल सुबह तो नहीं हो पाएगा क्योंकि कल सुबह मेरा मैथ्स का क्लास है, परसों सुबह मैं आप लोगों के लिए वीडियो रिकॉर्ड कर दूंगा स्पेशल, ठीक है। एक बार इस वीडियो को देखिए। जिन लोगों ने ये कॉन्सेप्ट्स नहीं पढ़े हुए हैं वो इन 2 वीडियोस को देख सकते हैं, एंड प्लीज डू लेट मी नो अगर क्लियर नहीं हुआ तो, देन आई विल डू इट, ठीक है। तो चलो ठीक है, फिर आज के लिए बस करते हैं, एंड आई विल सी यू टुमारो। टुमारो वी विल हैव स्टार्ट विद फ्लूइड काइनेमेटिक्स। तो कल हमारा पहला क्लास रहेगा, पहला क्वेश्चन कल हमारा जो क्वेश्चन रहेगा वो फ्लूइड काइनेमेटिक्स का होगा। हम 3-4 दिन फ्लूइड काइनेमेटिक्स के क्वेश्चन डिस्कस करेंगे वही डेली बेसिस पे, और फिर 3-4 दिन डेली बेसिस पे डायनेमिक्स के क्वेश्चन डिस्कस करेंगे। हाय अनीश, हाउ आर यू? थोड़ा लेट हो गए। ये अनीश होमवर्क क्वेश्चन दिया है, ये होमवर्क क्वेश्चन दिया है, और ये आज का क्वेश्चन था, ये वाला आज का क्वेश्चन था। हमारे पास एक कंटेनर है, उसमें पानी है, एंड इफ द कंटेनर मूव्स अप द इंक्लाइंड प्लेन, देन व्हाट इज द मैक्सिमम पॉसिबल एक्सेलरेशन सो दैट वाटर डज नॉट स्पिल आउट। तो ये आज का क्वेश्चन था, ठीक है। तो चलो ठीक है गाइस, कल मिलते हैं। थैंक यू सो मच, बाय बाय, सी यू टुमारो। हाँ, सॉल्व करके देखो, और कोई डाउट आए तो मैं हूं। और जिन्होंने टॉपिक नहीं किया है गाइस, मैं पहले ही बता रहा हूं, देखो ये जो मैं वीडियोस करा रहा हूं, मेरा मेजर एम ये है कि मतलब मैं ये एज्यूम करके कर रहा हूं कि आप लोगों ने ये टॉपिक्स पढ़े हुए हैं, और हम क्वेश्चंस के थ्रू टॉपिक्स को रिवाइज कर रहे हैं, ठीक है। सो अगर कहीं भी लगे कि नहीं ये टॉपिक हमें नहीं आता है तो आप मेरे को बता सकते हो, मैं उसको एक्सप्लेन कर दूंगा अलग से। दरअसल ये भी एक्सप्लेन कर सकता था अभी, बट बात पता है क्या है, ये थोड़ा सा लेंदी है, तो लेंदी का होने का मतलब कि इसमें टाइम बहुत लग जाएगा अगर एक्सप्लेन करना है। हाँ, तो अभिलाष बेटा उसका भी वीडियो बनाया था। मैं बेटा इसलिए बोलता हूं, मैंने ना जब भी कोई टॉपिक स्किप किया है तो उस टॉपिक को ना मैंने यूट्यूब पे डाला है, तो वो आपको यूट्यूब से उठाना था बेटा। तो रुक, मैं तेरे को टर्बुलेंस का भी सेशन ढूंढ के देता हूँ। फिर एक काम करो, आप उस पे हो ना, टेलीग्राम ग्रुप पे हो, तो मैं एक काम करता हूँ, मैं यहाँ से ढूंढ के आपको डाल देता हूँ। 1 मिनट रुको। तो ये होना चाहिए टर्बुलेंस का भी। मैंने कंप्रेसिबल फ्लो पे भी बहुत सारा वीडियोस बनाया था, तो एक बार मुझे ढूंढना पड़ेगा अब इस पे यूट्यूब पे। ठीक है, मैं आपको टर्बुलेंस का भी वीडियो भेज देता हूँ। वो टेलीग्राम ऐप पे, टेलीग्राम ग्रुप पे टर्बुलेंस का भी वीडियो भेज देता हूँ। मैंने जब लेमिनार फ्लो थ्रू पाइप्स की वीडियोस कराए ना यहाँ यूट्यूब पे, उसमें मैंने टर्बुलेंस भी सिखाया, तो ये उन्हीं दिनों की बात है। तो जो टॉपिक मैं क्लास में नहीं करा पाता था बिकॉज ऑफ शॉर्टेज ऑफ टाइम, वो मैं यूट्यूब पे डाल देता था। अच्छा ठीक है, तो मैं आपके साथ शेयर कर दूंगा फिर। चलो ठीक है गाइस, सी यू टुमारो, नेक्स्ट क्लास फ्लूइड काइनेमेटिक्स फर्स्ट टॉपिक, ठीक है। 1 टॉपिक 1 क्वेश्चन एवरी डे। थैंक यू, बाय बाय।